This video, we will look at another example of hypothesis testing on the mean using the p-value approach. Here is our example. A student group claims that first-year students at a university study 2.5 hours per night during the school week. A skeptic suspects that they study less on average. She takes a random sample of 32 first-year students and finds they study an average of 2.25 hours per night. Assume the population standard deviation is 0.75 hours. At a 5% level of significance, should we reject the student group's claim? Step one is to write down our pair of hypotheses. The claim hypothesis, again, we're checking the students group claim, is that the first year students study 2.5 hours per night. So their claim is that mu is 2.5 or mu equals 2.5 hours per night. So that's the claim. You want to write down that that is the claim. The complement of mu equals 2.5 is mu is not equal to 2.5. Once you've got those two down, the null hypothesis is the one with the equality, which of course is mu equals 2.5. So this is our null hypothesis, and this one is our alternative hypothesis. Step one is complete. Step two, what's our significance level alpha? They want us to do this at a 5% level of significance, so alpha is 0.05. Step three is to determine the tail direction and type of test. To determine the tail direction, we look at the alternative hypothesis. Since mu is not equal to, that means we have a two-tailed test. So we have a two-tailed. Now the question is, do we have a z-test or a t-test? Well, in this case, we are told to assume the population standard deviation is 0.75 hours. So we're assuming sigma is 0.75. So the population standard deviation is known. And we are also told that she took a sample of 32 first-year students. That 32 is greater than or equal to 30. That means that we are dealing with a z-test. So we're going to do a two-tailed z-test. The next step, step four, is to compute your test statistic. So we're computing the z-score, where we take x bar and subtract mu. X bar, we are given that the average time from her study was 2.25 hours, so that's x bar, minus mu, which is the hypothesized claim, which is 2.5, so minus 2.5, over sigma, we have is 0.75, divided by the square root of the sample size, which is 32. Again, when you plug this in your calculator, make sure you have parentheses around this numerator and parentheses around this denominator. And when you do that, you get approximately negative 1.89. On step 5, we need to compute our p-value and make a determination about whether we should accept or reject the null hypothesis. Again, you do not need to make a picture here, but I think it is very helpful. So we are doing a z-test, so we've got a standard normal curve. We found our test statistic to be negative 1.89, so that's over here, since of course the mean is a z-score of 0. So we want to find the area over here as an extreme value to the left of the test statistic, negative 1.89, but that is not our p-value. Because we are doing a two-tailed test, we have this area over here for which we would consider the test statistic to be an extreme value. So we need to get this area A. Then to get the p-value, since we're doing a two-tailed test, is going to be double that area. We're going to double A. So let's get this area underneath the standard normal curve to the left of the z-score, negative 1.89, from our formula sheet. And when you look at the formula sheet, you get A is 0.0294. So again, that is not our p-value. Our p-value is going to be double A, since that's just this area. This is a two-tailed test, so we need this all together. So we need to double that area A. That will give us a p-value of 0.0588. Now that we have our p-value, we also, in step 5, need to either accept or reject the null hypothesis. And again, to determine that, we need to compare the p-value to the significance level alpha. If the p-value is smaller than or equal in size to the significance level, we want to reject the null hypothesis. But if it's bigger than the significance level, then we want to accept the null hypothesis. And in this case, 0.0588 is in fact bigger than the significance level 0.05. So we are going to accept the null hypothesis. Remember, again, I'm using the word accept, and really what I mean is technically that we failed to reject. Again, they're not exactly the same, as you could see in a previous video, but accept is just easier to say. So in step 5, we found the p-value is 0.0588, and we have decided to accept the null hypothesis because that p-value was greater than the significance level alpha. And finally, in step 6, we need to make a statement about the claim and interpret our results. So we were told by the test to accept the null hypothesis. So that means we want to accept this thing here. And this thing is, in fact, the claim. So since we're accepting this and it is the claim, that means we're going to accept the claim. So we are doing this at 5% level of significance. So at 5% level of significance, we accept the student group's claim. That the average amount of time spent studying per night is 2.5 hours. At 5% level of significance, we accept the student group's claim that students study on average 2.5 hours per night. We have now completed another hypothesis testing on the mean using the p-value approach.